Hi, in this video, we're going to go through how to use a normal distribution, a normal curve, as well as kind of this interactive normal curve to solve one of the homework problems. So the homework problem states a TV manufacturer knows that their TVs have a normally distributed lifespan with a mean of 2.1 years and a standard deviation of 0.7 years. If a TV is picked at random, 7% of the time its life will be less than how many years? So we're going to draw, I'm going to start by showing you this normal curve I drew, this little sketch. In the middle should always be your mean. So I put 2.1 here in the middle. Every standard deviation, which our standard deviations are 0.7 years, I'm going to go out from the mean by that amount. So 2.1 plus 0.7 is going to be 2.8. And I add another standard deviation away from that is going to be 3.5, and then another one is 4.2. If I go to the left, I'm going to get 1.4 and 0.7 and 0. So we see how we kind of label each of the standard deviations in terms of the units of years that these TVs last. They don't last very long, in my opinion. 2.1 years isn't quite long enough for a TV. But we do know from the empirical rule that 68% of these TVs by this manufacturer then will last between one standard deviation below and one standard deviation above the mean. So between 1.4 and 2.8 years. 95% of TVs by this manufacturer will last between two standard deviations of the mean. So 0.7 up to 3.5 years. And then 99.7% of TVs by this manufacturer will last between 0 up to 4.2 years. So that's how we read a table like this. Now, to answer the question here, it's saying how if one's picked at random, 7% of the time its life will be less than how many years. That less than term is a key term to look at there. And it means that we're trying to find some point on the table where the percentage of area below that point is 7%. Now, the empirical rule is not going to be helpful for us for this problem. We need to dive deeper into the table, into the normal curve. And we can do that either through a table of numbers or through this interactive website I have here. So let me pull up the interactive website because I like how this one works. So this one I can choose, I can actually choose how I want to go about looking at the area of the curve. I can go from the right tail onto the left. And you can see if I can highlight it all, I get about close to 100% of the curve. I can go from the middle on up to the right, or from the middle to the left. Or I could go up to Z, which is what I'm going to do because I'm trying to find the amount of area under the curve to the left of some point. And I'm going to scroll this until I get to about 7%. 7% is the number I'm looking for within this problem. And it doesn't let me get exactly to 7%, but I can kind of hover between right below it, which has a Z-score of negative 1.48, to right above it, which has a Z-score of negative 1.47. So 7%'s got to be in between those two Z-scores. A Z-score tells us how many standard deviations away we are from the mean. So whereas on here, I couldn't exactly tell where the 7% would be, and it was somewhere to the left of the mean, but I didn't know exactly how many standard deviations away it was. When I look at the interactive curve, I can see the 7% under to the left of that spot. It's about 1.47 standard deviations from the center, about 1.5. The negative means were to the left. If it would have been positive, we would have been to the right, but we are about 1.5 standard deviations from the mean. Now, because it's between negative 1.4, what was it, between negative 1.47 and 1.48, I am going to kind of just take the middle of those two numbers and say that the Z-score we're going to use, this Z-score is going to be negative 1.475. That's right in between negative 1.48 and negative 1.47. So let's just use right in between. So I'm going to say this is a Z-score. Again, Z-score is the number of standard deviations away from the mean. And again, we found that from the normal curve interactive. So now that we know the Z-score is negative 1.475, that we are sitting at close to 1.5 standard deviations from the mean, then we can use our Z-score formula, which this formula will be given to you on exam 3 and on the final exam, to find out what this means in terms of how, if a TV is picked at random, it will be less than how many years? How many years what does that mean in terms of years? So I'm going to take the z-score of negative 1.475 on the left. That's my z. My x is what I don't know. That's the thing I'm solving for. I'm going to subtract the mean, which is this mu. I'm going to subtract the mean of 2.1, which is given in the problem, and I'm going to divide by the standard deviation, which is 0.7. When we do this and solve for x, we should get an x value of about 1.0675. And so that is telling us, let me write it more like this. Let's see. X equals 1.0675. X is standing for the number of years for this question. So it says to round to 1 decimal place, so we'll say 1.1 years. And that should make sense because it was more than one standard deviation from the mean. One standard deviation from the mean was this 1.4 right here. 1.4 attaches to that line right there. So it was more than one standard deviation from the mean. So it makes sense that it would be about 1.1. It wasn't quite 2 standard deviations from the mean, which would be at 0.7 years that it would last. So it was in between 0.7 and 1.4. So 1.1 seems like a reasonable answer. And that is the answer for this problem.